Okay, and welcome to Equity Education, the chemistry version, and today we're going to be looking at atomic structure. This probably will be familiar to you if you've studied any chemistry before, but we still have to do it, so let's crack on. Could you open your booklets and we will start. Okay, so atomic structure. So an atom is made up of three types of subatomic particles, these being, as you probably already know, protons, neutrons, and electrons. And you're probably familiar with this table as well, so we will go and fill it out. So protons, neutrons, and electrons, with our masses of 1, 1, and 1 over 2000. Our charges, positive 1, 0, and negative 1. So our masses are relative. They're not really 1, they're just given the value 1. And our mass of our electron is 1 over 2000. You may see different values for this, but the main point is that we say that the mass of an electron does not affect the mass of an atom, which will become important later on. And our charges, we're given again values of positive 1 for a proton, 0 for a neutron, and negative 1 for an electron. Okay, moving on. So, diagram of an atom. Again, you've probably seen these diagrams before, so let's have a go at drawing them. Okay, this is my very artistic drawing. So here we have a diagram of an atom, and in the middle we have the nucleus, and surrounding the outside, or orbiting around the outside, we have the electrons, and I've shown them as crosses. So this is a very basic diagram of an atom. Okay, so moving on. So the nucleus, the nucleus of an atom is made up of protons and neutrons. Electrons are found circulating the nucleus in shells or orbitals, depending on which book you are looking in or which syllabus you are doing. And the mass of an atom is found in the nucleus of the atom. So the whole mass of the atom is found in here, which means that most of the atom is actually space. Okay, so moving on. So we've got these electrons which circle around the nucleus of this atom, or moving around it. But why don't they just fly off? There must be some force of attraction, and we call this force of attraction, which keeps electrons circulating in the nucleus, as the electrostatic force of attraction. And we can describe the electrostatic force of attraction as the force between a positively charged particle and a negatively charged particle. In the example above here, our positive particle would be our nucleus, because it has protons and neutrons in, so it's positively charged, and our other particle, they are both subatomic particles, are the electrons. Another example would be if we use ions, for example. We could have sodium, which has a positive charge, chlorine, which has a negative charge, and when these are close together, there will be an electrostatic force of attraction. Okay, alright, everyone got it? Okay, moving on. So, mass number. Alright, so you have to know some definitions, yeah? So you have to memorize these, and you have to know them. So the mass number is the number of protons and neutrons in an atom. And we can also describe the atomic number as the number of protons in an atom. Okay, so now this is also important. So the atomic number defines the position of an element on the periodic table by counting the number of protons in the atom. Okay, so we can tell the position of an element by looking at its atomic number, or say it another way, if we're given the atomic number of an element, we can find its position on the periodic table. If you look at a periodic table, you will soon realize that the elements are arranged in increasing values of atomic number from left to right. Okay, so our next thing, calculating number of protons, neutrons in an atom. So if you look on a periodic table, you'll see two numbers. Two numbers here. So this is my mass number, and this is my atomic number. And from these two numbers, we can calculate the number of protons, neutrons, and electrons in an atom. So how do we do this? So these are my protons, neutrons, and electrons. So we'll start off easy. We know that the atomic number from our definition is the number of protons in an atom. Therefore this number is 12, so it must mean that we have 12 protons in this atom of magnesium. Now this atom is also neutral, it doesn't have a charge. And we know previously from our table, we go up, that our protons have a charge of +1. So that means we have a charge of +12, positive 12. To make it neutral, it must mean that we have 12 electrons to cancel out that charge. +12 minus 12 equals 0. Therefore we know our number of protons and we know our number of electrons. Working out the neutron number is slightly more difficult, so we can use this formula. So we can say the number of neutrons is equal to the mass number minus the atomic number, which is equal to 24 minus 12, which equals 12. So we can work out our number of protons, our number of neutrons, and our number of electrons from these two numbers. Okay, and as we said previously, an atom does not have a charge, it is neutral. And that's why our protons and our electrons must equal each other if we have an atom. Right, so your turn. I would like to have a go at completing the number of subatomic particles for each atom, and I'm going to give you them. So let's go with beryllium, and I will give you the mass numbers and the atomic numbers. Potassium, mass number of 39, and carbon, which I'm sure you've all seen before. Okay, have a go at these, and we'll go through them once you've completed them. Okay, right, so hopefully you got on all right. Let's have a go at working these out. So our protons, neutrons, and electrons. Hopefully you've worked out the easiest thing to do is our protons at the minute, because our protons never change, so it's equal to our atomic number, so it must be 4, potassium must be 19, carbon must be 6. Again, because they're atoms, our protons and electrons must equal, therefore 4, 19 and 6. And to work out our neutrons, we minus the mass number from the atomic number, which gives us values of 5, 20, how good's my maths, and 6. Okay, hope you all got that right, and we'll move on. Okay, so an ion is a charged particle. That's important, so we'll highlight it. So an ion is a charged particle. And I'm going to write some examples. Oh, actually, you have a go at writing some examples down, and we'll see if we get some of the similar ones. Okay, so some examples of ions are Na+, S2-, Cl-, Mg2+, and so on and so on and so on. Yeah. So you will notice that there is a charge in the top right hand corner of these, meaning that it's not neutral, therefore it is not an atom. So how do we form these ions? How do you think we can form these ions? I'll let you have a think about it and you can come back to me. Okay, so how can we form these ions? We've got to change the balance of charge. So our charges in an atom between the protons and the electrons is equal. So theoretically we could remove protons, or we could remove electrons, or we could add protons, or we could add electrons. That would change the charge. However, there's a problem if we add the protons. So if we add protons to change the charge, such as in sodium here, let's write sodium as an example. So we have sodium, and we'll write the mass number and the atomic number of 11 and 23. Okay, so if I add a proton, it would mean that I get a positive charge, but it would also mean that I have changed the number of proton, or the atomic number. If I change the atomic number, what happens? Well, we change the element. So we can't add protons to change a charge, which means the only thing that we're left with is that an atom can either lose or gain electrons. Now let's take our previous example of sodium. Sodium 23 and 11. So we have 11 protons. Now to get a positive charge, it must mean that I lose a negative charge. So that means I must lose one electron. So my proton number stays the same, my neutron number, 23 minus 11, let's try and work that out, is 12, and the electron number must be 10. Therefore I have 11 positive protons, 10 electrons, meaning I have an overall charge of +1. I hope that makes sense, because now it's your turn. Okay, so calculate the number of protons, neutrons and electrons in S2 minus 32, 16, Mg2 plus 24 and 12, and let's do a harder one, I minus 127 and 53. Now don't worry about the charges on the ions at the minute. There'll be another video which explains how we get these charges, how we work them out. Okay, so have a go at this, and I will see you in a minute. Okay, right, so we have our protons, we have our neutrons, and we have electrons. So it should be very simple to work out our number of protons, because that number never changes, which equals our atomic number. So it must be 16, 12 and 53. Now our electrons number has changed. So that means, depending on whether it's negative or whether it's positive, I need to add or take away electrons. Now here we have a 2 minus, so that means I must have added 2 more electrons. So I would have 18. Here I have a 2 plus, which means I must have taken away 2 negative charges. Therefore 10, 12 from 12. 12 minus 2 equals 10. Here I have 1 negative charge, 1 more negative charge, so I must have added an electron to get 54. Work out our neutrons. So 32 minus 16 is 16, 24 minus 12 is 12, and 127 minus 53 is 74. You can use a calculator if you need to for that one. Okay, moving on. Oh, so see if you can fill this out. So have a quick think about it. Okay, so notice that the number of protons never changes. The atom is changed to an ion, but it still belongs to the same element, and that's what we were talking about previously. If we change the protons, then we change the atomic number and we change the elements. Okay, so another definition for you to remember: isotope. So an isotope is an atom of an element with the same number of protons but different number of neutrons. E.g., okay, what shall we use? We'll use carbon. 13, carbon 14. So we have 3 isotopes of carbon which are stable and naturally occurring. Yep, so we can find them in different percentages in the Earth's crust. So what I would like you to have a go at is calculating the number of protons, neutrons and electrons in these 3 isotopes of carbon. Okay, have a go at doing this. Okay, so made this slightly more trickier. As you may have noticed, I only gave you one number. I only gave you the mass numbers. Therefore, you had to go and search up on your periodic table, which should be in front of you, I hope, and find out the atomic number of carbon, which is 6. Therefore, we can now work out the number of protons, neutrons and electrons in these 3 isotopes. We know that the proton number is not going to change. They are neutral, they are atoms, so they are neutral, meaning the electrons must equal. And the number of neutrons is mass number minus atomic number, so 6 here, mass number minus atomic number, 7, 14 minus 6, 8. So what's the only thing that changes? Obviously, the number of neutrons changes for each isotope. And if we look back at our definition, an atom of element with the same number of protons but different number of neutrons, well, we've just proved it by doing this example. Okay, now it gets to the harder part. Now it's your turn. Okay, so I've made you work a bit more harder than usual in this one, but I want you to do some more questions as well. So please have a go at doing these questions, see how you get on. The last ones are a bit tricky, yeah, so have a go. If you can't do them, it's okay, we'll go through them together. Okay, so let's go through the answers. So a 50p coin contains nickel alloyed with a metal A. Nickel exists as a mixture of 3 isotopes, nickel 58, nickel 60 and nickel 62. Complete the table below to show the atomic structure of the isotopes in metallic nickel. And again, in this question, like in our previous question that I gave you, we don't have an atomic number, so you're going to have to look on the periodic table, which is definitely in front of you by now. And we can figure out that the atomic number for nickel is 28, which means it's not going to change. We know that it's an atom, so it's going to be neutral, so our number of protons and electrons must equal. However, our neutrons is going to differ slightly. Yeah, so because we're going to take our mass number from our atomic number, which means that we're going to have 58 minus 28, which equals 30, 32, and 34. Hope you got that right. Moving on to the next one. Okay, so the group 7 element bromine was discovered in 1826. Bromine gets its name from the Greek bromos, meaning stench, because of its strong smell, and it definitely does smell. Bromine consists of a mixture of two isotopes, 79Br and 81Br. What is the difference between the atomic structures of 79Br and 81Br? You may notice that this is worth 2 marks. Yeah, so you probably have to say two things. So what can we say is the difference between the atomic structures of 79Br and 81Br? We can say that 79Br has 2 fewer doesn't have 2 fewer electrons, does it? Has 2 fewer neutrons compared to 81Br. Because it's worth 2 marks, I've stated how many neutrons it has fewer. You could also say that 81Br has 2 more neutrons compared to 79Br. So the fact that we stated the number of neutrons and shown that is the number of the actual neutrons which is different will give us our 2 marks. Okay, moving on. State 2 similarities between the atomic structures of 79Br and 81Br. Well, you can definitely state 2 of these. Our first one is quite obvious. They have the same number of protons, and also because they are atoms and they are neutral, they have the same number of electrons. Okay, right, so moving on to the hardest table. How did you get on with this? Right, we'll take it individually. So let's work this out. So first of all, you have to make sure that you fill out the atomic number. If you don't know the atomic number, you can't get this right. We know the atomic number of magnesium must be 12 because we have 12 protons. There is no charge up here, therefore we must have 12 electrons. Easy to start off with. Moving on. Protons. Right, so we have 12 protons. I know then that it must be magnesium. Yeah, because the atomic number of magnesium is 12. Therefore I can fill out my atomic number here. I can also fill out my protons and neutrons because I can add them together to get my mass number, which is 24. But something's different between these two. I only have 2 electrons, which means I have lost 2 negative charges, which must mean I have a charge of 2 plus. Got it? Okay. Moving on, our next one. We again know the number of protons, so we can look on the periodic table to figure out what element it is, and we find out that it is nitrogen. We can also write the mass number on there, which is 13 from the periodic table. 14 from the periodic table, which must mean that my neutrons is 14 minus 7 equals 7. And I have 3 more electrons than protons, so I must have added a negative. I've added 3 electrons, so I must have a 3 negative charge. And last but not least, aluminium. Okay, so I need to look at aluminium on the periodic table to work out its proton number, which is 13. So I can give my proton number, which is 13. I can work out my protons, and I can work out my neutrons from minusing my mass number from my atomic number, which gives me a value of 14. And I have a value of 3 plus, so I must have lost 3 electrons, which means I only have 10 remaining. Okay, so hope that was helpful, and I will see you next time back here. Okay, goodbye.